this is our minor project named Quantum Tic-tac-toe. So this game is entirely different from the classical tic-tac-toe that we usually play. Uh, this is built in Python using the Qiskit library. So let me show you the demo. It is it's taking a while. Okay. So as in the interface, you can see we can play with AI and play with two players. So let's first try with playing with two players. So you can see we can choose X and O. So in the classical tic-tac-toe, what we do is after choosing X, we only check we click any one of the boxes and and that's where the X is kept, and then the opponent's turn comes where the opponent will choose O. But in this game, it's not it's not like the classical tic-tac-toe, but we have to choose two boxes like this. So so you might be wondering what are these two boxes. So these two boxes are like is the superposition state. In quantum mechanics, there are three basic or most important concepts like superposition, entanglement, and collapse. So superposition means, for example, if you flip a coin in the middle, you never know that either it is uh, heads or tails. So in that state, it is superposition. Until it is collapsed, you never know either it is head or tail. So likewise, these two these two uh, position in the board are known as superposition. And this is the circuit. This is the quantum circuit right now. So this is the Polish X gate, and this is the hammer gate, and you can see the 0 and 1 position are connected using this one hammered gate, one Polish X gate, two Polish X gate, which shows superposition. Now let's take O. Okay, so you can see in the second and the fifth. This is the second and the fifth position. There is superposition again in the circuit for O, but for O this time, right? So again, like you can see in the classical tic-tac-toe, we only choose one position, but here we are choosing two position. So now again it's axis turn. Yeah, you can see the circuit is being updated. Like for now it's for third and the fourth, right? And then again it is O's position now. Okay, you can see the circuit here. Finally, when you choose one X, then remember in the zeroth and the one position in the boxes there are two axes, and after collapse it will only be appeared as one. Just like after the coin drops in hand, it is either head or tail. So likewise, if I click here X, now the board is collapsing. Now will return in the classical tic-tac-toe. Okay, so this is the measuring. These measuring gates are used for the collapsing. So all these circuits which was in the quantum state, all these were in superposition. After measuring, all the circuits were collapsed, and likewise the classical bits were written. So yeah, remember in this zeros and one position there were two axes. So now after collapse there is only one x, right? And there was two O's. Now there is only one. So now we play the classical game. Okay, now it's X's turn. and so is done. Okay, so you can see player X wins. Now let's play again. Now let me show you the another concept of um, quantum mechanics, which is entanglement. So entanglement is basically mm, like if there is something happening in one room. Suppose there are two coins in two separate rooms, and if if a coin flips and results in head, then the another coin in the next room must come tails. So if one coin affects the nature of another, then that is known as entanglement. So like in nature, the sunflowers are always facing towards the sun, which is another example of entanglement. So let's see now. We have to first let's select two axes in the 0th and 1 position of the boxes. Now, now if you select O in the already existing axis position, then this is now known as entanglement. This position right here. So in this position, either there will be X or O, or there won't be anything. So now we choose O here, and then X's again, then O's again. So now for O, let's do entanglement. Okay, like this, something like this. Now, now in this position, if okay, so we choose. So if there is nothing in this position, then there must be X here and there must be O here. If there is X here, then there must be O here. If there is O here, then there must be X here. So this entanglement is affecting both the X and O, X's and O's, which is X's and O's, right? So now it's O's done. Now let's collapse the board. So okay, for the entanglement, uh, the circuit is okay for entanglement. For the entanglement, I'll show you the circuit later on. So after collapsing, the X already wins here. So let's play again, and let me show you the entanglement circuit. So this is position up until now, but if I select O here, so this is O and O here, right? So this 0 and 1 was in superposition, but now the 1 and 0, 1 and 2 are in entanglement state here. So this is the circuit for entanglement. Okay, so let's just randomly play after collapsing. Oh, X solution. So now let's try with AI. All right. So again, we have to choose a player. Then if we choose X, the AI will be by default O. Then so these concepts might be a little too overwhelming, but slowly if you do research by yourself or try to understand these concepts, it can be easier to grasp. Let's choose X. There was some problem. There was a glitch. So let's play with AI. This is done. Now is AI done? Okay. Is AI done? Collapsing the board. Okay, it's AI is done and AI wins here. So unlike in the classical tic-tac-toe where the AI always either wins or if you play correctly, it is going to be it is going to result in a draw. But with this quantum tic-tac-toe, the tree, like we have to choose two two states or two boxes, right? So due to which the tree or competition tree will be so large that AI also might lose. So this with this game we can easily visualize the concepts of quantum mechanics and teach anyone quantum mechanics very easily. So that was the main goal of this project. Thank you.